All right, guys, we are continuing what we started with factoring. And I want you to remember back when we were graphing parabolas and we had this intercept form and it looked like this with our a times x minus p, x minus q. Well, what did the p and q tell us? Remember, it told us p and q told us where the x-intercepts. Or in other words, it's where the parabola crossed the x-axis. So it told us where that was happening. So one of them would be the p and the other one would be the q. And that's what was nice about the intercept form, is we could see exactly where it was crossing and we knew where the axis of symmetry was and so on. So we already know how to put something that's in factored form into standard form. We did that when we were graphing. We would FOIL that out and get it in standard form. Well, now what we're going to do is go backwards. We're going to put standard form into intercept form because this is very useful for finding the x-intercepts. So remember on our last quiz, we did a lot of solving and we did either square root on both sides or we did quadratic formula. So now we're going to solve using factoring, and we're using this idea of the intercept form. Okay, and so here's the deal. The p and q told us the x-intercepts because what we were really doing was solving this equation. We were solving this is equal to 0. So here's a property that I don't know if you've seen before. It's called the zero product property. And here's what it says. If I have any two numbers, okay, I'm just going to call them A and B. If I have A times B, and I know that it's equal to 0, well, what do I know about those two numbers? So think about it. If I asked you, okay, I've got two numbers and I know they multiply to equal 0, what would you tell me about either A or B? Well, if we know this, then we know that either A has to be 0 and or B has to be 0. One or both of them has to be equal to 0 in order for them to multiply to equal 0. So that's called the zero product property, and we're going to use that to help us solve these quadratic equations. So in standard form, we would solve this and we would use either quadratic formula or we would use square roots on both sides. Well, now what we're going to do is we're going to take this equation and we're going to factor it and then use the zero product property. So let me show you how we do that. So we've been factoring, and remember we would say, okay, I need two numbers that multiply to equal this last number. So multiply to equal 9. And then remember we had to look at this sign here, and we would say those same two numbers have to add to equal that middle term, negative 10. And then we would look at all the factors of 9. So if I look at the factors of 9, I've got 1 and 9 and 3 and 3, and that's about it, right? So which of these add to equal 10? Well, 1 plus 9 equals positive 10, but I need them to equal negative 10. So we would need these to be negative 1 plus a negative 9 in order to equal negative 10. So the question is, if I do negative 1 times negative 9, will those still equal 9? Well, sure they will, because a negative times a negative is a positive. So we know that our two factors are not going to be this one, they're going to be this one right here. So negative 1 and negative 9 are what's going to go in our parentheses. So in factored form, we know that these are be x and x, because x times x gives us x squared, and then I would have x minus 1, x minus 9, because the 1 and the 9 are both negative. So the only thing new we're adding is we're saying, okay, this factored form is equal to 0, so we're going to set each factor equal to 0, just like we did with a and b. We said either a has to be 0 and or b has to be 0. So rather than a, I have x minus 1. We know that has to be 0. And then I have x minus 9. So rather than b, I have x minus 9 equal to 0. So these are very simple equations to solve. How would I solve these blue equations? Well, on this one, I would add 1 to both sides. and I would get x equals 1. Over here, I would add 9 to both sides, and that would give me x equals 9. So these are my two answers for this equation. So rather than doing quadratic formula or square roots on both sides, all we did was factor it and set each factor equal to 0 when we got our two answers. Remember, these are the x-intercepts of the parabola, or that would be like the P and the Q if we were doing this in intercept form. So we know that the parabola would cross at 1 and then cross at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here and here, I know the parabola is crossing there. All right, let's do some more. So we're going to solve this equation. This is on the back of your sheet. So if I do this, remember we're going to factor this. We're not going to do quadratic formula. We're going to factor. So we need two numbers that multiply to equal 48, and they also have to add to equal 14. All right, so let's look at our factors of 48. So I've got 1 times 48 equals 48, 2 and 24, 3 and 16. If you don't know how I'm getting these, you can use your calculator to help you get these. So 4 times 12, and then 6 times 8. Oh, I'm running out of room. And then that's all. Those are all of my factors of 48. So which of these pairs also adds to equal 14? Well, that would be this last one, 6 and 8. So remember, 6 plus 8 will give me positive 14. So those are the numbers I want in my parentheses. So when I factor this, I know I'm going to have x and x. And then the numbers inside are going to be plus 6 and plus 8. So now our added step, we're going to set each factor equal to 0. So each parenthesis gets set equal to 0. And you don't have to write the parenthesis over again. You can just write x plus 6 equals 0 and x plus 8 equals 0. And it's very simple to solve. Subtract the 6, and then we get x equals negative 6. And then we would subtract the 8, and then we get x equals negative 8. So you see that all that happens is it becomes the opposite of what number was in parentheses. So that's why we always said P and Q had to be opposite. Let's do example 7. So we need two numbers that multiply to equal 6. And this time they're going to subtract to equal, what number is this? This is negative 1. So I need factors of 6. So that's 1 and 6 and 2 and 3. Which ones subtract to equal 1? Well, that's this pair. So is it 2 minus 3 equals? That equals negative 1. I always like to try the other way just to make sure I'm getting the correct order. So 3 minus 2 equals positive 1. I don't want this one, I want the one that equals negative 1 because we want negative 1. So these are the numbers I'm going to have in my parentheses. All right, so in factored form, I'm going to have x and x. I'm going to have positive 2, so x plus 2, and I'm going to have negative 3, x minus 3. So now just set each factor equal to 0. Solve them, and you get x equals negative 2 and x equals 3. All right, now in 8 and 9, notice that these are not in standard form, so we need to get everything on one side equal to 0 first. So make sure you do that before you try to factor. Okay, so this is just like when we set it up for quadratic formula, we need to have it equal to 0. So same thing for factoring to solve. All right, so we need to subtract the 14. Remember, when I subtract the 14, that doesn't combine. I just rewrite it. So I have x squared plus 5x minus 14 equals 0. So now I can do my factoring. Two numbers that multiply to equal 14. And I have a subtraction sign there, so they need to subtract to equal the middle number, which is 5. So factors of 14, I've got 1 and 14, 2 and 7, and that's it. So which ones subtract to equal 5? That would be this one. So do I do 2 minus 7? That would give me negative 5. Or do I do 7 minus 2? That would give me positive 5. Well, I want positive 5, so I want this pair and not this pair. All right, so let's factor that. In parentheses, that would be x plus 7 and x minus 2. So set each factor equal to 0. Solve those simple equations, and we get x equals negative 7 and x equals positive 2. So our last one, again, we need to put that in standard form. So I'm going to add the 4x to the other side. So that's going to give me x squared plus 4x minus 5 equals 0. And we are looking for two numbers that multiply to equal 5. And we've got subtraction, so I need to subtract to equal 4. So let's look at our factors of 5. Well, 5 is pretty easy. There's only one pair. It's just 1 times 5. Let's hope that they subtract to equal 4. Yeah, so if I do 1 minus 5, though, that'll give me negative 4. I want to make sure I'm doing 5 minus 1 to give me positive 4, because this is a positive 4 in the middle. All right, so my factored form will look like, I want this one, not this one we said. So I want a positive 5, x plus 5, and minus 1 because of that. Okay. So set each factor equal to 0. Sorry, that's a negative 5. That looks sloppy. X equals negative 5. And then I have x equals 1. So now we have a really nice short way to solve as long as we can factor it.